All right, hi everyone. So this is the solution video for the April 1 worksheet. So there are three sets of compounds here, and you're supposed to rank these from strongest to weakest in terms of their acidity. Now, if you look at these, there's a whole bunch of different organic functional groups represented here. So in the top row, we have an alkane, we have an alkene, and we have an alcohol. Now remember, alkane and alkene, that's that hybridization. So the alkane is weaker because it's sp3, the alkene is stronger of those two. But both of these are still very, very weak. Alcohol here, the pKa is around 16. So this is even still quite weak, but of the three, this is going to be the strongest. And then again, between these two, this will be the middle one, and the alkane will be the weakest. Okay, so again, this is the hybridization, alkene stronger than alkane, but still very weak, and alcohol even is still quite weak, but it's stronger than the others. Middle one, same sort of a thing. We have alkene, alcohol, and carboxylic acid. Well, acid is in the name of this one, so that's going to be the strongest. And alcohol and alkene, we talked about that in the first one. So for this one, alcohol is going to be number 2 and alkene number 3. So again, 1 is the strongest, 2 is the middle, 3 is the weakest. And then down on the bottom, we have 2 carboxylic acids here, one with a CH3 and one with a CF3. So that's the inductive effect. So the one with the fluorines is going to be the strongest. The other one is going to be second, the acetic acid. And notice here, this is an amine. Now amines normally we would call bases. So if something is a base, that means the conjugate acid is going to be very, very weak, right? So this is actually going to be number 3 here. That's a very weak acid. You can remove an H from that, but again, the pKa of that is something like 40. It's very, very, very weak as well. Okay, so that's the 3 sets of them for the acids. And now let me go through and do the bases, right? And that one list of bases that's there, I'll draw them up here in a second, are the conjugate bases of some of these acids. Right, so we have CH3, CH2, CH2 minus, so that's the conjugate base of an alkane. Here we have CH3, CH2O minus, that's the conjugate base of an alcohol. And then here we have CH3, CH2NH minus, so that's the conjugate base of an amine. Okay? So of these, alkane is a very, very, very weak acid. So the conjugate base is going to be the strongest. So this is the strongest. Alcohol, again, of these 3, still quite weak, but was the strongest acid originally. Was the strongest acid originally. So that means this, even though we would consider this fairly strong, of these 3, this is going to be the weakest base. And again, that's because the alcohol, the original molecule, was the strongest acid of the 3. And then, of course, this one's going to be somewhere in the middle. Okay, so there was and again, relationship between acid and these, the conjugate base. Very weak acid equals very strong conjugate base and so forth. Okay, and the last one, the second one, was simply to complete some acid-base reactions involving organic molecules. So the first one was this trifluoroacetic acid. So that's the acidic hydrogen. And an amine was the base. So this nitrogen is the base. So again, we're transferring the H from the acid to the base. So what we end up with is trifluoroacetate. Okay, so we've removed the H from there. And now that gets transferred to here, so we have CH3, NH3, and now this is positively charged. So this H plus got transferred from here to the nitrogen. Okay, so that was the first one. I'll erase this top part and we'll do the second and third ones. And again, these are all H plus transfers. So this one is an alcohol, CH3, CH2OH, and again, that's the H on the alcohol, that's the acidic one. And this one I used the pyridine, so we talked about this one in the intro video. So that's the base, so again, here's your base, the nitrogen, it's an amine. So once again, the H is going to get transferred, so we have CH3, CH2O minus, This H has been removed, and now it's been added to here. So the base has picked up the H, and that's now positively charged there as well. So again, the H got transferred from the alcohol to the purity. And then last but not least, we have the conjugate base of an alkyne, so that's a base, and we have just the plain acetic acid. Again, that's the acidic one, so I'll put this kind of in the middle here. So that's the acid, this is the base, so we're going to transfer the H. So we're going to have HC, triple bond CH, and this now is neutral, because when this H plus gets transferred to here, the positive charge and negative charge cancel one another out. And then again, we're left with acetate. So CH3, C double bond O, O minus, okay? And if you look at all of these things, right, the charges need to balance. Notice these two are neutral, so we have a negative and a positive. Those cancel one another out, the overall thing is neutral. Here again, we have neutral, a negative and a positive, overall cancel out neutral. Here we have an anion and a neutral, so in our products, we have a neutral and an anion. Again, everything has to balance out. Okay, so again, on Friday, we'll be starting to look at Lewis acid and base. See you all then.